Hey guys, so hopefully you can hear me. Hunter is not happy right now, and Alex is trying to calm him. I've been looking at your static electricity work that's within our electricity unit, and I've noticed there's a lot of either missing work or incorrect work, and I don't know if it's because we're not really paying attention or we're just guessing to get it done, or if because we're not together and I'm not there to explain it to you that maybe all the information is overwhelming and you're just kind of like out of it. So I thought I'd make just a quick kind of basic video that talks about the vocabulary words you should know. Um, Hopefully, this helps a bit. And I simplified the original slideshow that you were supposed to view like last week, just so that we can kind of gather our thoughts. And hopefully, if you have questions, reach out to me. Rory's laying down. So, we're going to continue static electricity this week and maybe even a little bit into next. But after that, we're getting into like electrical circuits and current electricity, so it's going to build from there. So let's just talk about static for now. All right, so what is matter? Anything that has mass and takes up space. So anything that's got volume, weight to it and takes up space. So everything you can see in your room has matter. It's made up of something. So what makes up matter? These invisible things called atoms. So in an atom, this is what it looks like. Okay? An atom has a center to it called a nucleus. Okay? Inside the nucleus is a proton that has a positive charge, a plus sign, and neutrons that don't have any charge. They're neutral. They're not positive or negative. They're nothing. So if I asked you, how do you feel about ice cream? And you don't love it, you don't hate it, you're just like, you're neutral on it. Okay? Protons, positive charge, neutrons, neutral. They're in the center. They're not moving, they're staying still. Then, kind of like a planet, you have these electrons going around or orbiting the center part. Electrons have a negative charge. Electrons can bounce from one atom to another. Because they can bounce around through the rubbing together and friction, they can create items that then get a more positive charge because as they leave this atom, protons take over. There's more of them. Or a negative charge because if they're jumping to a new one, this is gathering more and more electrons and it's becoming a negative charge. Okay? So it says most objects have a neutral charge. Everything balances out. They have the same number of positive and negative charges. So when you look at something, it's got neutral charges right now. Okay? Since protons and neutrons are located inside, they're held very tightly. Like I said, they're not moving. The electrons can jump. So here, there we go. We have 3 electrons and 3 protons, and then we have our neutrons that are white that aren't anything, so it doesn't matter how many because it balances out with the red and the blue. Okay, they're balanced. All of a sudden, this atom rubs against something else, and these electrons jump to another atom, and now we went from having 3 to 6. So now this has a negative charge because it has more electrons, which are negative, than the red protons. Okay? These can't move. Only the electrons can move. So when it has more red protons, I'm saying red even though we don't have a color for them, just to help you with the vision of it. When there's more of them, it's a positive charge. This one has more red, it's positive. This one has more of the electrons on the outside, more of the blue, so it's a negative charge. Okay, so the whole idea is that atoms have a center, which is a nucleus made up of protons, positive, and neutrons, neutral. And then around the outside, you have electrons that move and they're negative. Okay, so static electricity is the buildup of electric charges on one object. This happens when you have friction, you rub things together. If I have a hat on and I'm taking the hat off, it's rubbing my hair. If I have a balloon and I put it on my head and I rub it, I'm creating friction. My socks on the rug. Static electricity happens sporadically because of the movement of the electrons. Okay, it's not like a light that we can turn on and off. It's the buildup. So this is when an object has too many protons or too many electrons. Okay, it needs to disperse it. Okay, static electricity does not flow through wires. Static means not moving. The electrons move and jump, but the static electricity is not something we can take and then harness and then use it later on to go through wires, okay? If the charge is strong enough, it jumps from one object to another, and that causes that shock, that zap that you feel. The best thing is the doorknob, especially in the winter when the air is really dry. That really helps with the electricity. So here you have your atoms, you have your nucleus, protons and neutrons, you have your electrons going around. And because this has more protons and this has more electrons, it's going to attract and zap. Static electricity is going to happen, okay? So like I said, charging an object is the friction. To create the movement, I keep rubbing my hands, of electrons together, it needs to be a rubbing of two things, okay? The object will gain electrons, and then it'll have a negative charge. The object that loses the electrons now has more protons, so it's going to have a positive charge. And because they're opposites, they're going to come together. So here, I don't know if this will work. Here I have a balloon with 4 protons, 4 electrons. They should be orbiting, but we're kind of playing a game with this, okay? If I take this to the sweater, oh, it's going to open it. Ooh, fancy. Maybe, maybe not. Okay, let's see if it works now. Yep, so I take it to the sweater and I rub it. This is friction. It's collecting electrons. The electrons are jumping from the sweater to the balloon. Now, the sweater has a positive charge, and the electron, or the balloon, has a negative charge because it has more electrons. Okay? Remember, protons don't move because they're in the center. Electrons move from the outside. They jump. So now, I have to let go of it, and it attracts to the sweater because negative and the positive are opposite, and opposites attract. So they stick together. Now, if I bring it to the wall, what happens? The electrons move away so that the protons can attract to it because opposites attract, and now it's staying still. So when you rub something, it's friction, and electrons will go to one item, it will gather them, which leaves more protons in another, and then opposites attract to it. That means like things repel or go against each other. Okay, let's see if I can go back. Okay, so if you walk across a carpet on a dry day, your body will gain a negative charge because electrons are moving from the carpet to your socks. And then your hand, you now have a negative charge because of that. You're going to touch something metal that electricity likes, and they're going to jump those electrons from your body to the doorknob. And because you have so many and it happens so fast, you feel that charge. It's called an electric discharge. They move so quickly, you feel that zzz, that happens. Okay? And that's the last thing I want to talk about. So the main ideas that I wanted to make sure that you are getting is that we have atoms that make up everything. We have our nucleus, the center, that has protons and neutrons. Protons are positive, neutrons are neutral, there's nothing. And around the outside are our electrons, and they move and move and move. When you rub items together, if I rub my hands on this little ottoman I'm sitting on, rub them together, go ahead and rub the pillow. I'm then taking the electrons and they're jumping. Okay, so then one thing gets a positive charge because it loses the electrons, and the other thing has a negative charge because it gathered the electrons. And then opposites attract, so certain materials would then stick together. If I walk across the carpet and I'm using that friction and gathering electrons, my body's now got a negative charge. And if I touch something that electricity likes, those electrons want to go to that, and it creates that zap, okay? So make sure opposites attract. Like things repel, they don't like each other. Positive and positive, negative and negative, nope. And that friction causes the electrons to move or jump to get either a negative charge or leave a positive charge, okay? And to get static electricity, that zap, you need to make sure you're touching something electricity likes, and that's going to come up in the future lessons about conductors and insulators, things electricity likes, conductors, and things that they don't like, insulators. So if I created it and all of a sudden I touched something else and it didn't do it, the electrons are still leaving your body. It's just not a force that you feel the zap because it's not something it's attracted to. I hope this isn't too long. I hope this helps you. Please go back and use the resources as we do these worksheets. Please ask me for help. I'm happy to video chat with you to go through it. So I just want to make sure that you have some information. Maybe me talking about it will help a little bit, but I'm going to put this in the 21st. I'm going to put it in Tuesday the 21st science box just so if you need it. All right. So have an awesome day. Contact me if you need me. I'm going to go do our morning video now for tomorrow.